Dear students, very good afternoon. Today we are going to discuss about how to derive mean and variance of Poisson distribution. Okay, so we are deriving the mean and variance of Poisson distribution by means of moment generating function MGF, moment generating function. So we are going to first derive MGF, and after that we are going to derive mean. Okay, and after that we are going to find variance. Okay, variance for Poisson distribution. Okay, Poisson. Okay, Poisson, Poisson distribution. So for Poisson distribution, using the moment generating function, okay, we are going to derive, or we are going to find the mean and variance. Mean and variance of the mean and variance for the particular distribution called Poisson distribution by means of moment generating function. Okay, so the Poisson distribution is given by P of x equal to small x. P of x equal to e power minus lambda power x by x factorial. E power minus lambda power x by x factorial, that is equal to that is varying from x equal to 0, 1, 2, etc. Okay, 1, 2, etc. and this lambda is always greater than 0. This lambda is always greater than 0. Okay, now the moment generating function formula is common for all distribution. Mx of t, okay, mx of t equal to, okay, mx of t equal to, what is our mx of t? E of e power tx. E of e power tx. E power tx. E of e power tx, that is equal to, okay, that is equal to summation x equal to 0, okay, x equal to 0 to infinity, okay, x equal to 0 to infinity, e power tx is given now, so e power tx into p of x. E power tx into p of x equal to x. P of x equal to small x. So P of x equal to x, that is equal to summation x equal to 0 to infinity e power tx into e power minus lambda power x divided by x factorial. Okay, and here we can write this e power tx as summation x equal to 0 to infinity e power t whole power x. Okay, e power t whole power x, then e power minus lambda into lambda power x divided by x factorial. Here the summation is varying from x equal to 0 to infinity. So here e power minus lambda is a constant that is unchanged for all the values of x varying from 0 to infinity. So e power minus lambda of summation lambda e power t whole power x divided by x factorial. Here x varies from 0 to infinity, x equal to 0 to infinity, so we are getting e power minus lambda into so what we can do, we can expand this. When I am substituting this x equal to 0 and here also 0 means it will become anything power 0 will become 1 divided by 0 factorial is 1. Okay, anything power 0 is 1, 0 factorial is also 1, so I am simply putting 1 plus lambda e power t. Okay, 1 plus lambda e power t plus lambda e power t the whole square divided by 2 factorial. Lambda e power t by 1 factorial plus lambda e power t the whole square by 2 factorial plus etc. Okay, we know there is a formula 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. means it can be written as e power of, okay, it can be written as e power of x, e power of x. So in such a way the whole expression can be written as, the above whole expression can be written as, okay, m x of t, m x of t equal to mx of t equal to e power minus lambda into e power minus mx of t equal to e power minus lambda into, this whole thing can be written as, instead of x we can put lambda e power t, so e power minus lambda into e power lambda e power t, okay, e power t, that is we can take e power lambda as the common element, and if it is e power lambda means it is e power lambda into minus 1, so we are having e power lambda of e power t minus 1, e power t minus 1. Okay, this is our mx of t, okay, e power lambda into e power t minus 1. So now we have to differentiate this mx of t with respect to t, and after that we have to replace okay, after that we have to find mu 2 dash, that is mean square value, and after finding that we can find the variance, okay, we can find variance, okay. So for that, now, so students, dear students, listen, now we are having mx of t equal to e power of minus lambda into e power lambda e power t, and this is equal to this. So instead of this I am going to consider this, because here I am having the constant separately from the main term, okay, this is our main term and this is constant because this only involves t. So I am considering m x of t, okay, I am considering m x of t equal to e power minus lambda, which is constant, that is it is free from the element t, it is free from the variable t, so e power minus lambda into e power lambda e power t, okay, e power lambda into e power minus lambda into e power lambda e power t, okay. So here, so we know that the first moment is mean mu1 dash equal to d by dt of m x of mx of t equal to mx of t at t equal to 0, at t equal to 0 equal to mean, then mu 2 dash, this mu 1 dash, next is mu 2 dash equal to d by dt of mu 1 dash or d square by dt square of m x of t mx of t at t equal to 0, which is equal to d by dt of mu 1 dash d by dt of mu 1 dash at t equal to 0. At t equal to 0 is the mean square value. Mean square value. Mean square value. Now so we are taking this mx of t, so d divided by dt of d by dt of m x of t, d by dt of m x of t equal to d by dt of mx of t equal to e power minus lambda is constant, and this is e power ax, means what we will get e power x, so that is lambda e power t into e power lambda e power t. This is our d by dt of mx of t at t equal to 0 means we get d by dt of m x of t, d by dt of mx of t at t equal to 0. At t equal to 0 means we get e power minus lambda into e power 0 is lambda into e power into e power 0 is 1, so lambda into e power lambda into e power lambda, that is equal to e power minus lambda into e power lambda will become e power minus lambda plus lambda, that is e power 0. So I am writing here lambda into e power minus lambda plus lambda that is equal to lambda. So what is our mean? Mean equal to lambda. Now after this we want to find d square by dt square of mx of t. To find mean square value, d square divided by dt square of dt square of m x of t, d square by dt square of m x of t, that is we can simply write it as d by dt of d by dt of what we are having here, d by dt of this value. This is our equation 1. No, this equation 1 is already one time differentiated. So d by dt of lambda e power, okay, lambda e power, so e power t into e power lambda e power t, lambda e power t. Okay, now see, we are having 1 e power minus lambda outside, so that will be written here, that will be actually written here, c equal to e power minus lambda d by dt of this. So now I am taking d divided by dt of d by dt of lambda into e power of, what are things are there, e power of base are common and powers are different, so we can add up powers, t, okay, plus lambda e power t minus lambda equal to d by dt of lambda e power, so we can take so here see, just a minute, here we can separate the constants. Okay, we can consider constants, which will be more easy than the previous step. Okay, here we shall consider constants separately. Here constants are nothing but the terms not having t as a one of t as one of the term. Okay, that is lambda e power minus lambda is constant. Okay, so that can be taken outside into e power lambda into t e power t, e power lambda into e power lambda plus e power lambda e power t, okay, plus t. Okay, now in this we shall take the constant outside, lambda e power minus lambda d by dt of 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 e power lambda e power t plus t. Okay, so this is e power x, this is in the format of e power x, so we can differentiate it and we can write lambda e power minus lambda of e power lambda into e power t plus t e power t plus t into so on differentiating this we get lambda e power t plus 1 lambda e power t plus 1 okay lambda e power t plus 1 at t equal to 0 we get d square divided by d t square of m x of t okay m x of t at t equal to 0 is a mean square value, that is mu 2 dash. So we get lambda e power minus lambda into e power of okay e power of 0. It will become 0 and it will become 0 means it is e power lambda. So e power lambda into e power 0 is 1. So e power lambda into 1, e power lambda into 1 is lambda plus t is 0. So we get simply e power lambda into here lambda plus 1 into lambda plus 1, that is lambda e power minus lambda then into lambda e power lambda then plus okay plus e power lambda plus e power lambda. So this is equal to lambda, so this is e power minus lambda into this is lambda square e power minus lambda plus lambda will become e power 0 and it will become 1 plus so lambda into e power minus lambda plus lambda is plus lambda square plus lambda. So this is our mean square value, that is mu 2 dash equal to what is that lambda square plus lambda okay. So that is e of x square. Okay, this is nothing but mean square value e of x square equal to lambda square plus lambda square plus lambda. And here it is mean. So what is mean? Mean is nothing but e of x. It means nothing but e of x. So e of x equal to our first moment equal to mu 1 dash equal to lambda. So how to find variance? So variance of x is given by variance of x equal to we can use any of the following formulas: e of x square e of x square minus e of x dash whole square, e of x dash whole square, or we can use mu 2. Okay, this variance is given by mu 2 equal to mu 2 dash minus mu 1 dash square. Okay, we can use either one of the formula. The value is lambda square plus lambda square plus lambda minus lambda the whole square. So which implies variance of x equal to which implies lambda, variance of x equal to lambda, because lambda square plus lambda minus lambda square, so lambda square will get cancelled, so we are getting variance of x equal to lambda. So for Poisson distribution, both mean and variance are same and they are equal to lambda, so mean equal to lambda is important result, variance equal to lambda is important result, and mx of t, okay, and mx of t equal to e power minus lambda into e power lambda e power t, or e power lambda of e power t minus 1. So at any one of these two formulas are important for mx of t, that is moment generating function. This is moment generating function. Mx of t is moment generating function. Either this formula or we can use this formula. Okay, we can use this formula. Okay, so I hope you all understood the problem and I hope you enjoyed this video. Thank you all for watching this video. Thank you all once again.